Modeling a material aims at computing a particular property given the geometry and the physical condition of such material. Inverse design wants to go the other way around. So given a desired property, what is the geometry that will lead to that particular property? For example, let's say we want to optimize this material to have the lowest thermal conductivity given some constraint. Then an inverse design algorithm will move these pores around in order to achieve the given condition, also subjected to constraints. For example, we still want to keep high electrical conductivity and low thermal conductivity. We did the MIT Quest for Intelligence. We are attaining this project by using machine learning algorithms. And this is a research that has been funded by MIT, IBM, Watson AI Lab. Within this collaboration, we aim at minimizing the thermal conductivity by using a so-called surrogate model of OpenBT. And why do we need that? Well, if we substitute a solver of partial differential equations with a neural networks, we are able to interrogate the system very quickly. So the first step is to create a surrogate model of our solver that an external optimizer can interrogate frequently. So this has been done by deep learning. The second step is optimization. And in collaboration with IBM and colleagues at MIT Aeroastro, we are developing an algorithm that can ensure low thermal conductivity of these materials while we keep the mechanical stability high. As we said, one of the main steps in developing an innovation is simulations. This has two outcomes. One is the result of the simulation itself, and the other one is the simulator that has been used. Having the simulator out in the world is very easy. So if you want to transfer the simulator from your own lab to the whole world, it just takes really some work to make the simulator user-friendly. You click the repository from private to public, and that's it. So that's really the easiest transition from your lab to the world. When it comes to a new material, of course, the process is a little bit more complicated. So let's say we start from a simulation that can narrow down 10,000 configurations to 100, and then we collaborate with an experimentalist that can actually fabricate those structures, and then we can intensify the research of the 2 or 3 structures that are more promising. And then we have to optimize the process, eventually starting a startup, and then we have to collaborate with a bigger company that has to mainstream this product. It's very complicated, and it takes from 1 to 10 years.